Welcome to my YouTube channel. Today we'll be discussing probability, but we'll start with addition law of probability. Probability is such that it can occur in three different forms. It's either the probability is certain, your result will be 1, or it is not certain, your result will be 0, or it is in between. It's either here or there. You have fractions in different form. But we need to understand this basic principle of probability so that as we journey through this series of probability, you'll be able to identify and solve different questions in probability. All we are going to be doing is to ensure we understand the rudiments, because questions on probability can be framed in different forms, but the moment we understand the basics, we'll be able to attempt or tackle any question of probability. As you can see on the screen, this is recognized. Now, we want to talk about addition law. When you see addition law, it is recognized by the word or. This or. Whenever you see or in probability, it means they are referring to addition law. This is recognized by the word or joining the probabilities, e.g., if PA is the probability of event A happening and PB is the probability of event B happening, the probabilities of event A or event B happening is given by PA plus PB, that is or. That is the addition. Whenever you say or, it means you are adding, provided events A and B are not mutually exclusive, that is A and B events which cannot occur together. Similarly, the probability of event A or event B or event C or and so on to event N happening is given by PA plus PB plus PC plus and so on to Pn. So whenever you see or in probability, you are being referred to add such probability. And in probability, the basic principle is the probability of what you are looking for over the total number of occurrences that is happening. As we journey through this question that we have on the screen, you understand better. So I want us to pay attention so that the moment we understand these basics, we'll be able to solve any question in probability, provided it is addition law. Kindly stay glued to this channel because we'll be treating a whole lot different forms of probability. We'll go through multiplication as well, and also we'll go through different forms of probability. Now, we have some questions here. Let's see how we can tackle them. Awesome. We have two questions here. Question number 1. In a crowd containing 20 men and 33 women, find the probability of selecting at random A man, B a woman, C a man or a woman. The second question, what is the probability of obtaining a 4 upward with 3 throws of a fair die? So let's say solution number 1. Let's say solution 1. Solution 1. Beautiful. Now, we need to take note of what we are actually doing. In a crowd containing 20 men, so we'll come here and say number of men. how many? We need to bring out our parameters. It's very key. Number of men is 20. Men. Then we have 33 women. Number of women, we have how many of them? 33. Awesome. So total number of people there now. We need to put into consideration that too. Total number of crowd. Total number of the crowd. Total number of crowd, that is 20 plus 33. That will give us what? 53. Awesome. So with that, this is going to guide us a whole lot in solving this question. So we have 20 men, we have 33 women. The total number of crowd there now is 53. Awesome. So we have to find the probability of selecting at random. So at random. So for A, at random, the probability of selecting at random a man, the probability of selecting at random a man will be what? Now, the probability of men all over, the total number of men, the total number of men all over the total number of crowd. That is, you remember I said earlier when I was giving my explanation, in looking for probability of what you are looking for over the total number of happening or occurrence in that situation. This time around, we are asked to find the probability of selecting at random a man. But the total number of men here is 20. So the probability of selecting at random a man will be what? The total number of men. Let me get the template here. Total number of men over the total numbers of crowd. Okay, let's just say number of men. Number of men over the numbers of crowd, or number in crowd, as the case may be. Awesome. With this, we can now say what is the total numbers of men. We've been able to iron that out. There are 20. We have 20 men. Because we have to look for the probability of selecting at random a man. So we have 20 men. Total numbers in crowd, we have how many of them? 53. Awesome. So, can this cut out? This is a proper fraction anyway. Can they cut? No, I'm not sure, because if we say 2 can go in 20, 2 cannot go in 53. So that means we are going to leave our answer in this form. So that's the probability of selecting at random a man from this crowd. Awesome. The second question says, for B, we should find the probability of selecting at random a woman let's make use of all what we have here as a template. Beautiful. This time around, the probability of selecting at random a woman. The probability of selecting at random a woman. So here we say number of women over number in crowd. We have how many numbers of women? 33 of them. The numbers in crowd, we have 53 of them. Can this cut? No. So we leave our answer like so. The probability of selecting at random a woman is 33 over 53. Awesome. Now for C, we have to find the probability of selecting at random a man or a woman. Don't forget, this or is addition. When you say or in probability, it means for you to add. Okay, let's make use of this as a template as well. We are going to, it's just a template. So for C, the probability of selecting a man, probability of selecting at random a man or a woman. The probability of selecting at random a man or a woman will now be probability of selecting a man plus probability of selecting a woman. Don't forget that this time around we are making use of off. So the probability of selecting at random a man or a woman will now be what? The probability of selecting a man let me make use of this. The probability of selecting a man plus the probability of selecting a woman, because we are asked to find the probability of selecting at random a man or a woman. Beautiful. Great. So the probability of selecting at random a man or a woman will now be the probability of selecting a man plus the probability of selecting a woman. Don't forget that the question says, did you find the probability of selecting at random a man or a woman? Since we've been able to find the probability of selecting at random a man, which is 20 over 53, we've been able to find the probability of selecting at random a woman, which is 33 over 53. Now it will make our job easier to find the probability of selecting at random a man or a woman. So this is for woman. Okay. Plus. Awesome. So probability of selecting at random a man is actually 20 over 53. Beautiful. And probability of selecting at random a woman is 33 over 53. So we are going to add this together. Now, don't forget, like we've said earlier, we've said it over and over again, if you are adding or subtracting fraction, you can get to watch our video on addition of fraction or subtraction of fraction. You'll be making use of LCM. So now that we'll be adding fraction, let's make use of LCM. It is very key. Now, what is the LCM of 53 and 53? That's 53. Good. How many times? Sorry, LCM of 53 and 53 is 53. How many times will 53 go in 53? That's 1. 1 times 20, that's this 20 that we have here. Plus, because we're actually adding 53 in 53, that's 1. 1 times 33 will give us what? 33. Awesome. So, if you are to add what we have here, (23) plus 20 plus 33, that will give us what? 53. Awesome. So 53 divided by 53 will give us what? 1. What this is telling us, if you remember, at the beginning of the question I said probability is in 3 forms. If it is certain, it will be 1. If it is not, it will be 0. If it is in between, you have different forms of fraction. Now, the probability of selecting at random a man or a woman, it is definitely going to be 1, because it's certain that is, if you don't pick a man, you pick a woman, because it's only a men and women that is in that crowd. That is for question number 1. So let's go to question number 2. What is the probability of obtaining a 4 upward with 3 throws of a fair die? So let's come here and say solution number 2. Awesome. Now, a fair die has 6 sides. We are aware of that. Okay, let's put it down for record purpose. A fair dice has how many sides? 6 sides. We are aware of that. Now, because we are being told that we should find the probability of obtaining a 4 upward with 3 throws. That means this fair die, we are throwing it up 3 times. So what is the probability of obtaining 4 upward? So we are going to do for the first throw, for the second throw, and for the third throw. Now, for the first throw, now, because we are throwing 3 times, the probability of obtaining 4 upward for the first throw now, the probability of obtaining 4 upward is either you obtain 4, that's just once. It's either you obtain 5, that's just once, or you obtain 6. So the probability of obtaining 4 upward will be, since 4 appear only once and the fair die has 6 sides, that means 1/6. So for the first throw, the probability of obtaining 4 upward will be what? Just 1/6. Because, let me use this as a template. So for the first throw, the probability of obtaining 4 upward is 1/6, because it's either you obtain 4, or you obtain 5, or you obtain 6. These 3 numbers appear only once. Now, that is for the first throw. The same thing applies to the second throw, because we are told that we have to throw it up 3 times. For the second row, the probability of obtaining 4 again, or 5, or 6 will still be 1 over 6, because those numbers appear only once, and the numbers in the fair die, they were 6. And likewise, for the third row, we will still have the same thing. The probability of obtaining 4 upward will still be 1 over 6, because 4 appear only once, or 5. So if you did not get 4, you will get 5. If you did not get 5, you will get 6. Awesome. So if you throw the fair dice up 3 times, the probability of obtaining 4 for the first, obtaining 4, 5 or 6 for the first row will still be the same thing for the second row, will still be the same thing for the third row. Now, therefore, I'm just putting it down so for record purpose. The probability of obtaining 4 upward with the 3 row of fair dice the probability of obtaining a 4 upward with 3 row of a fair die will definitely give us the probability of first row, or the probability of second row, or the probability of third row. Or the probability of second row, or the probability of third row, because that is what we have. Or the probability of what? Third row. Awesome. So, therefore, the probability of obtaining 4 upward with 3 row of a fair die will equal the probability of first row, or the probability of second row, or the probability of third row. By so doing, we know that the probability of first row is 1 over 6. The probability of second row is 1 over 6. And the probability of third row is also what? 1 over 6. Therefore, probability of first row, or the probability of second row, or the probability of third row, since we've been able to establish that all is addition. Beautiful. So we have, let's get this as a template. So what is the LCM of 6, 6 and 6? It is 6. It is very easy. It's as simple as that. How many times will 6 go in 6? 1. 1 times 1 will give us 1, plus 6 and 6, 1. 1 times 1, 1, plus 6 and 6, 1. 1 times 1 will give us what? 1. Beautiful. So 1 plus 1 plus 1 will give us what? 3. Awesome. Now, let's get this as a template. This can be our answer, but it can cut out, so we don't leave it that way. We cut it out. 3 can cut here, 1, 3 can cut here 2. So we'll be left with what? 1 at the numerator and 2 at the denominator. So that will be our final answer. So the probability of obtaining a 4 upward with 3 row of dice will be 1 over 2. You can always pause, rewind this video for better clarification and understanding. Kindly help drop a comment if you have any issue with any of our videos. Help like this video and subscribe to this YouTube channel, My Simple Maths. And you can help us press the notification bell so that you can always receive notification from us whenever we post a video. Thank you.